Multiplying with Fractions, Part 1 by Jeff Simpson, MasteryLearningSystems.com. This is a lesson for students who are learning to multiply with fractions for the first time, or for students who tried before but didn't get it. Using pictures to think about fractions is very helpful. So here are some pictures to get you ready for multiplying with fractions. This box is cut into 3 equal parts. One of the 3 parts is blue, so 1/3 of the box is blue. Now, 2/3 of the box is blue. Here is 1/3 of a chocolate cake. Here's another third of a chocolate cake. Let's put them together on the same plate. 1/3 plus 1/3 is 2/3. We can add the fractions. 1/3 plus 1/3 equals 2/3, or we can multiply them. 2 times 1/3 equals 2/3. 2 times because there's 2 of them. This box is cut into 4 equal parts, and one of the parts is green. 1/4 of the box is green. Now 2/4 of the box is green. Now 3/4 of the box is green. Here's 1/4 of a chocolate cake, and here's another 1/4 of a chocolate cake, and another 1/4 of a chocolate cake. Let's put them all together on the same plate. There's 1/4 plus 1/4 plus 1/4, and that equals 3/4 all together. We just added them, but we can multiply 3 times 1/4, which of course is 3/4. This box is cut into 2 equal parts, and one of the 2 parts is purple. That's called 1/2. Now, some people actually want to call it 1/2 because they see the number 2, but that sounds like a tooth that's in your mouth, so we don't call it 1/2. And some people want to call it 1/2, like 3rd grade, 2nd grade, 1/3, 1/2. And that's logical, but that's actually not what we call it. It's just called 1/2. Not 1 1/2, just 1/2. So 1/2 of the box is purple. Here's a change. Now 2/2 of the box are purple. This box is not cut into smaller parts. It's just one whole box. There is just one part. And the one part is purple. So one whole box is purple. One whole box means one box that is not cut into smaller parts. 1/1, you read that as one whole. Now let's compare one whole to the other kinds of fractions. For example, here's 1/4 and 1/3. Here comes 1/2. And finally we have one whole. One whole is the same as just one. Here's one whole again. One whole is a little strange. It's not what you'd expect a fraction to be. Well, isn't a fraction supposed to be a part of something, you might think? Proper is a good word to use here. Proper means correct or appropriate, or the way something is supposed to be, like proper behavior. This is a picture of a proper fraction because it is a part of something like you would expect a fraction to be. Now here we have 1/4 and 1/3 and 1/2. These are all proper fractions because they're part of one thing, like you think fractions are supposed to be. Improper means not correct or not appropriate or not the way something is supposed to be, like improper behavior. 1/2 is an improper fraction because it is not a part of something like you'd expect it to be. It's the whole thing. Here are 2/2. Let's see what happens when we add them together. There's 1/2 plus 1/2. Well, that gives us 2/2. 2/2, you read that as 2/2. So 2/2 of the box are purple. But actually, that's the same as 1/2 box, which is the same as just 1. 1/2 box is purple. And that is an improper fraction. A common mistake that people make with a problem like this, 1/2 plus 1/2, is to add the numbers first on top, the numerators. And actually, there's nothing wrong with that. That's good. Problem is that then they add the bottom numbers, the denominators. So you got 2 plus 2, which gives you 4. But that's not good. You might think, why not? What's wrong with adding the bottom numbers, the denominators? Well, the picture tells us what is true. If we do 1/2 plus 1/2, we can see that it does equal 2/2, or 1/2. But you're going to see something wrong now. Here's a box cut into 4 parts. There's 1/4. There's 1/4. Why do we have fourths here? Well, we got 2/4. 1/2 plus 1/2 equals 2/4? Well, sure doesn't look like it when you look at the picture. Somebody must have added the numbers on the bottom, but that's not right. No, this is not true. Adding the bottom numbers, the denominators, gives us false information. Now this box is cut into 12 equal parts. And we've got 1, 2, 3 of the 12 parts are blue. So we say that 3/12 of the box is blue. And that is a proper fraction. Stop the video, please, and write down this problem and solve it. 1/4 plus 1/4 plus 1/4. Okay, do that now. Should you add the numbers on top, the numerators? You know, like 1 plus 1 plus 1 and get 3? Should you add the bottom numbers, the denominators? Should you do 4 plus 4 plus 4? And get 12? Well, let's see if adding the bottom numbers would make sense. As always, the pictures will tell us what is true. If we have 1/4 and another 4th and another 4th, and we put them together next to each other, there's 1/4 plus 1/4 plus 1/4. You can see that it does equal 3/4. But here comes something wrong. This box is cut into 12 parts, and 1, 2, 3 parts, that's 3/12 are green. Well, if you do this wrong, and you add the numbers on the bottom, the denominators, 4 plus 4 plus 4 is, you get 12. The thing is, this is not true. Adding the bottom numbers gives us false information. When we say 1 purple box, 1 is just a regular number. But when we say 1/2 box is purple, 1 whole is an improper fraction. But 1 whole is actually just the same as 1. Here are 2 whole boxes. Each box has just one part. What are we going to do with this? So it's called 2 wholes, or 2 whole boxes. 2 whole boxes are purple. 2 over 1, you read that as 2 wholes, is the same as just regular 2. And 2 wholes is an improper fraction. Here are 4 whole boxes, and each box has just one part. So we write 4 over 1. And we can see 1, 2, 3, 4 boxes are purple. That's 4 whole boxes. 4 whole boxes means 4 boxes that are not cut into smaller parts. 4 whole boxes are purple. 4 over 1, or 4 wholes, is the same as 4. And 4 over 1, 4 wholes, is an improper fraction. Well, here's a question for you. Is 3 over 1 the same as 3? A picture will tell us if that is true. Here are 3 whole boxes, and each box has just one part. And we've got 1, 2, 3 whole boxes are purple. So yes, 3 wholes, or 3 over 1, is the same as 3. And that's an improper fraction. You've seen several examples of adding fractions, like this, 1/4 plus 1/4 plus 1/4 equals 3/4. But what do pictures of multiplying fractions look like? Let's begin with pictures of easy multiplication. Let's show 2 of these, for example. Okay, there we got 2 of these $5 bills. We can add them, 5 plus 5, and of course that equals $10. Or we can multiply. Since there's 2 of them, we can say 2 times 5 equals 10. Here's another picture of easy multiplication. Let's show 3 of these. Okay, we've got 3 $10 bills, and we can add them. 10 plus 10 plus 10 is 30. Or we can multiply. Actually, this is a little quicker. 3 times 10 is 30. Now, let's multiply with fractions. Let's show 3 of these. Okay, there they are. 3 of those 1/4. Well, we can add them, as we've done before. 1/4 plus 1/4 plus 1/4 equals 3/4. Or we can multiply 3 times 1/4, and we get 3/4. Sometimes, though, people get confused with this kind of problem. Should they multiply 3 times the top number? And they're not sure. Or maybe they should multiply 3 times the bottom number. They're not sure about that either. But maybe they should multiply 3 times both of them? Well, a picture makes it clear what you should do. We can see that 3 times 1/4 is 3/4. So, yes, we do multiply 3 times the top number, the numerator. 3 times 1 is 3, just like it shows in the picture. And the bottom number, the denominator, does not change, because they're still just fourths. Someone invented a clever way of dealing with this. Since we know that 3 over 1, or 3 wholes, is the same as 3, we can rewrite a problem with a 1 under the 3. I'll show you what I mean. See the 3 there? Well, underneath the 3, we'll put a 1. Why would we want to do that? Well, because now both amounts have a numerator. They both have a number on top, and they both have a denominator on the bottom. Now, multiply the top numbers, the numerator times the numerator, 3 times 1 and we get 3. And multiply the bottom numbers, the denominator times the denominator. 1 times 4 is 4. And that we know is true from the picture. 3 over 1, same as 3. Does this way of solving problems always work? Well, let's take a look at another example and see. Let's show 2 of these. Okay, there's 1/3 and 1/3. Let's put them together now, side by side. We can add them. 1/3 plus 1/3 equals 2/3, or we can multiply 2 times 1/3 equals 2/3. Now, let's do this problem the new way. Rewrite the problem with a 1 under the 2. Okay, under the 2, we'll put 1. Now, multiply the numerators. 2 times 1 is 2. And multiply the denominators. 1 times 3 is 3. And that matches with the picture. We know this is true. Of is an important word in these multiplying situations. Yeah, of. For example, 2 of these, notice I said of, 2 of these, and we can write that as 2 times 5. Notice, of and times have the same meaning in this situation. Or, with this situation, 3 of these. 3 times 10. Of and times, same thing. Also works with fractions. 3 of these, well, we've got 3 of these 1/4. Yes, of and times still mean the same thing. Here's another example, a little more complicated. Well, 3 of these, well, what is this? That's 3/10 if you count them. How are we going to have, what does that mean? 3 times 3/10? How much will there be altogether? Well, let's make a picture and find out. There is one group of 3/10. And there is another group of 3/10. Now we've got 3 groups of 3/10. 3 times 3/10, or 3 groups of 3/10 equals 9/10. Now let's do this problem the new way. Rewrite the problem with a 1 under the 3. Okay, we got a 1. Now multiply the numerators. 3 times 3 is 9. And the denominators. 1 times 10 is 10. 9/10, yes, that goes with the picture. We know that this is true. Here's a different kind of example based on a heart shape. A whole heart looks like this. Well, as a cartoon anyway. And we write it as 1 over 1, 1 whole. A half heart could look like this. 1 over 2, 1 half. Or it could look like this, 1 half. If you take 2 halves and put them together, 1 half plus 1 half equals 1 whole, or just 1. You get 1 whole heart. Now let's show 4 of these halves. 4 of these is the same as 4 times this, 4 times a half. But what does that give us? Let's put them all in this little box here and find out. There's 1 half, 2 halves, 3 halves, 4 halves. Now let's take 2 of those halves and turn them around the other way, and we get 2 hearts. That's a picture of 4 times 1 half. Well, let's rewrite this problem and then multiply. First, we want to put 4 over 1, and then multiply the numerators. 4 times 1 is 4, and the denominators, 1 times 2 is 2. Now we've got a number over a number, 4 over 2, so that tells us to divide. So we have a box for dividing. We'll take the number from the top, the 4, put it inside the box, and the bottom number goes outside. 4 divided by 2 is 2. So, yep, that's our answer, 2. 4 times 1/2 is 2. Something interesting happens with multiplication when you switch the numbers around. 2 times 5 is 10, we all know that. But what if you put the 5 first and the 2 after it, and you multiply 5 times 2? Well, you still get 10. The answer, or the product, the result, is still the same, even if you switch the numbers around. Yeah, that's the commutative property. Well, the product stays the same, but this is interesting. When you represent each problem with pictures, the pictures are not the same. This is so strange. For example, you got two of these 5s. That's 2 times 5, which makes 10. Now watch this next picture. A bunch of $2 bills. Yeah, they do exist. And there's 1, 2, 3, 4, 5 of them. 5 of these. That's 5 times 2, which is also 10. So the products are the same, 10 for both of these, but the pictures are very different. The same thing happens when we multiply with fractions. For example, instead of 4 times 1/2, let's do 1/2 times 4. Switch the numbers around the other way. Well, the product will still be the same, even if the numbers are switched around. But what does the picture look like for this kind of problem? 1/2 times 4. Here's a hint. Remember that 1/2 times 4 is the same as 1/2 of 4. 1/2 of 4. If there were, let's say, 4 heart-shaped cookies, and you got to keep half of them, there, you get half of them. You'd have 2 cookies, because 1/2 of 4 is 2. Now let's do this problem the new way. Rewrite the problem with a 1 under the 4. So now we've got 1/2 times 4 over 1. Multiply the numerators. You get 4. Multiply the denominators. 2 times 1 is 2. And when there's a number over a number, like 4 over 2, we divide. So we take the top number, the 4, and put it inside the box. Always the top number goes inside. And the bottom number goes outside. 4 divided by 2 is 2. So 1/2 of 4 is 2. We knew it from the picture.